Hey everybody, this video is going to be about converting quadratics from standard form into graphing form. And so the graphing form is the one that I have there on the top right. And so let's take an example. So let's say that we have um, x squared minus 2x minus 8. And I need to re-express this in this format like this. Well, when the a is 1, when there's no coefficient on the x squared, it's easier than if there were a coefficient. So let me just do this example without the coefficient. So I would always look at the first two terms that have the x, and I would basically complete the square based on those two terms. So completing the square here would mean that you divide the b by 2, and then you square that. And in this case, the b is negative 2. And so that would give you minus 1 squared, which of course is positive 1. So what you need to complete this square here is you just have to add 1. So what I'm going to do is I'm going to say this is x squared minus 2x minus 8, right? We haven't changed anything there. And I'm going to add 1. But I can't just arbitrarily add 1 just because I feel like it, because I would be changing the expression. And so I also have to subtract 1. What this helps me with is that now I can take this and factor it into a perfect square. So this actually becomes x minus 1 squared. And minus 8 minus 1, that is negative 9. So this now is in the proper format where my a is 1, my h is 1, and my k is negative 9. That's my first example where the a equals 1. That, I think, is the easier one. Let's go do one that's just a little bit harder. So we have here 2x squared plus 8x plus 4. And we need to convert this into the AHK format. So first of all, there's two different philosophies. One is that you would factor out the a from all the terms. However, I prefer just to factor out from the first two terms. So what that means is I have to divide by a so I can get the x squared by itself. So I'm going to take a 2 out. Actually, I'll leave that one blue because it is the same 2. But we are factoring that out from the first two terms. So that would be x squared plus 4x plus 4. Okay, but we're not done because that is not a perfect square yet in the middle. Remember, a perfect square would have to be something that is in this format, right? Because that would be a plus b squared, and I could convert that to that. And so I need something. So my 4x is like my 2ab. This thing right here is like my 2ab. So if 4x is actually 2ab, then in order to get to b, I have to divide by 2. And the a is the x, so I have to divide by 2x. So that would leave me with 2. And then I square that to get my b squared. And so my b squared would be, in this case, positive 4. So let us write some of these things. So let's do this again. I'm not going to change anything. I'm just going to move it around a little bit. So what I'm saying is that I took the 4, which is the b, and I divided it by 2, and I squared it. And that gave me 2 squared, which is 4. And so this right here, I want this to be a plus 4. But again, I can't just arbitrarily add things in. So you might think, well, Okay, then I'll just subtract 4 and even it out. No, that is not okay because we didn't actually add 4 because the 4 is actually inside the bracket. Actually, what we really added was 8 because 2 times 4 is 8. And so that's positive, so we have to subtract 8. So that gives us 2 times x plus 2 squared, and 4 minus 8 is negative 4, minus 4. So here my a is 2, my h is negative 2, and my k is negative 4. One more? Okay, so let's do one more with maybe a negative. So we have negative 2x squared minus 12x plus 6. Okay, so again, I would look at the first two terms and I would factor out the negative 2. So I'm looking at this right here, and I'm going to factor out the minus 2. So I'm going to say minus 2, put my brackets, bracket, bracket. So divide everything by negative 2, I would get x squared. And then this would become plus 6x. And this over here stays the same. So now we need to complete the square. Again, completing the square is always b over 2 squared. I'm talking about the b inside the bracket. In this case, the b is 6. So 6 over 2 squared is 3 squared, which is 9. So I need to add 9 inside the bracket. So let's make a little bit of room here. And we are going to add 9 inside the bracket. Let me use a slightly different color. We need positive 9. And it's always going to be positive inside that bracket because b squared in the 2ab, remember how it's a squared plus 2ab plus b squared? It's b squared is what we're actually getting. And so because it's squared, it's always going to be a positive value. So we're going to add 9 in, but that doesn't mean it's going to end up a positive value. And so this is exactly what I needed to point out because this gets tricky. I added 9, but I can't just willy-nilly add 9 just because I feel like it. So I have to balance that out. So do I just subtract 9? Is that what you think you do? No. And many of you do think that. I know from experience that lots of people think that. No, because we didn't actually add 9. No. Actually, what we did is we subtracted 18. What? What do you mean subtracted 18? Well, look again closely. In order to get this plus 9, I actually, if you FOILed this out, if you, distributed this out, it would be negative 18. And so what we contributed to this expression is we actually subtracted 18. So in other words, we have to add 18 on the other side because we have to balance that out so we're not changing the value of the expression. So what does this become? All in all, we get negative 2. And this is then x plus 3 squared, x plus 3 squared. And I did that because I did the perfect square because that was the whole point of completing the square. So we'd have a perfect square. And then 6 plus 18 is 24. And so we get a is negative 2. H is negative 3. Don't forget about the flipping of the sign for the H. And K is 24. Thank you very much. Oh, and then, of course, you graph it. HK is the vertex. So in this case, the vertex would be negative 3, 24. And it would point down because the A is negative, and it would be twice as wide as a normal parabola. Twice as narrow. I almost made that mistake myself. Twice as narrow as a normal parabola because remember, a larger the absolute value being larger on the coefficient makes the parabola narrower. And something where the absolute value of the coefficient is smaller, like a half or a tenth, makes the parabola wider. So thank you very much. I will call it right here.